Hello guys, welcome to the code space. In this video, we are going to solve today's POTD of lead code. Let's have a look on the problem statement. It is given that there are n cities and these cities are connected with a path. The paths are given by the edges matrix where edges of I of 0 represents the starting point of the path and the edges of I of 1 represents the destination of the path and the edges of I of 2 represents the distance of the path, and you are also given an integer threshold distance. It is the Let's assume a person is traveling from a city 1 to another city, then the person can only travel maximum distance of threshold distance. So we have to return if the is we have to return a city from which the person can travel minimum number of cities from compared to all other cities. For example, in the example 1, the city 0 is connected to city 1 with a distance of 3, and the city 1 is connected to city 2 and as well as city 3. The distance between city 1 and city 2 is 1, and the distance between city 1 and 3 is 4, and the cities 3 and 2 are connected with a distance of 1. If we see the city 0, we can travel, and it is given that the threshold distance is 4. If we assume the person is standing at 0th node and he can traverse to 1 and 2 cities, that means he can traverse two cities with a threshold distance of 4. Coming to the city 1, the person, if the person standing at city 1 and by traveling at maximum of 4 distance, he can traverse through city 3 and city 2 and city 0. This means he can traverse total of 3 cities. Coming to city 2, he can only traverse to city 1 and 3, total of 2. Sorry, he can also traverse to the city 0. It means he can city 2, for the person from city 2 can traverse at most of 3 cities. And coming to the city 3, with a minimum distance of 4, the person standing at city 3 can go to the city 1 and city 2. So the total of 2 cities he can traverse. It is given in the problem that if two or more cities can traverse a minimum distance, then we have to return the city with the highest numbered. So, according to that statement, the solution of this problem becomes 3. To solve this problem, I used a adjacency matrix distance, and the logic I used is if 3 cities are connected, I will select one city from the all cities. That means this operation takes an order of n. Let's name this node as k, and I will take another node I that I can traverse from the kth node, and this node can be anything from the nth nodes, so it is also an order of n. And I will take another node from which I can that node which I can traverse from this ith node, and it can be anything from the nodes n. So the total time complexity of this approach is n cube. If we go to the constraints, the maximum number of n is 100. That means my approach will take 10 power 6, which is acceptable. So I will made a new connection from k to this node j with a distance of this. Let's this distance is d1 and this distance is d2. then the total distance is d1 plus d2. Hence, I make a new connection between kth node and jth node if my d1 and d2 is less than or equal to dh. Let's go through the code. Here, this 2D matrix is used as an adjacency matrix, and I made all the distance between a node to itself as 0, and I made the pre paths of the given edges list, and I checked that if my I of k is less than int max, that is, if I can traverse from the kth node to ith node, and if the distance between the kth node and the jth node is less than int max, then I make I distance of I comma j minimum of these two values. And finally, I will count the number of cities that I can reach from the each node. And if my count is less than the previous value of the min, then the answer is replaced with the I. Hence, finally, I will be the node with minimum cities will be stored in the ANS variable, and I will return the ANS variable. So this is the solution. I hope you like this video. If you like this video, please like and share to your friends. If you want to get new updates from our channel, please subscribe to our channel. Thank you for watching.